Welcome to CSEGURU. In this session, we will discuss the topic types of recursion. Already, we have discussed what do you mean by recursion and what are all the examples to implement recursion. The best examples of factorial function, Fibonacci series, GCD of two numbers and finding exponent. So these are all the examples already we have discussed. Now we are going to discuss the types of recursion. So recursion is a technique that breaks down the problem into one or more subproblems. The given problem, it will divide it into one or more subproblems and it will find the solution for these subproblems, and if you are combining the solutions of these subproblems in the sense, you will get the original problem solution. So, whenever you are dividing the given problem into subproblem, it will be similar to the original problem. How we are going to solve the original problem and what is the code required or steps required to solve the original problem, the same steps is required to solve the subproblem also. Only the value varies here. So, if you are finding the solution for these subproblems and if you are combining that solution in the sense, finally you will get the original problem solution. That is nothing but recursion. Any recursive function, if you are considering in the sense, there are three main categories here. It may be a direct recursion or indirect recursion, or it may be a tailed recursion or non-tailed recursion, or it may be a linear recursion or non-linear or otherwise called a tree recursion. So if it is a direct recursion in the sense, when the recursive function calls itself directly. So recursion is simply nothing but function calls by itself. So when the recursive function directly calls itself in the sense, that is called direct recursion. Indirectly calls itself in the sense, it is called indirect recursion. Through other user-defined function, if the recursive function calls itself in the sense, that is indirect recursion. Tailed recursion in the sense, whenever if there is any pending operation need to be performed at each recursive call in the sense, that is called a tailed recursion. So each recursive call step, if there is a pending operation, the next recursive call you have to make it, but there is a pending operation need to be performed. In that case, that is called tailed recursion. And non-tailed recursion in the sense, whenever you are making a recursive call, there is no pending operation. Everything is completed. Only the recursive call you have to make it and you have to implement it. That's it. That is called non-tailed recursion. And a linear recursion, if you are considering in the sense, based on the structure of the calling pattern. Linear in the sense, in every recursive call step, the function calls by itself only one time. Every recursive call, only one time. And tree recursion in the sense, every recursive call more than one time the same function calls by itself in the sense, that is called tree recursion. All these three categories we will discuss with example now. Direct recursion. A function is said to be directly recursive if the function explicitly calls by itself. Okay, explicitly the same function, if it calls by itself in the sense, that is called direct recursion. This is simply called recursion. And here if you are considering the example, this is the function. Here you need to pass n value. If n value is 0 in the sense, just it will return n as the result. When you are giving input value, n is 0. Suppose other than 0 value if you have given as input in the sense, in that case it will return function of n minus 1. For example, if n value 5 if you have given in the sense, in the first recursive call, it will call with function 4. Okay, this is first recursive call. And second recursive call, it will call with function n minus 1. n is 4 now, n minus 1, 3. Next step. Third recursive call, function of 2. Fourth recursive call, it will call with function of 1. And fifth recursive call, it will call with function of 0. And when n value is 0, it will return n as the result. 0 as the result it will return. So here, explicitly in each recursive call, the function calls by itself. This is the user-defined function. Function calls by itself. For all the positive values of n here, it will call directly. The recursive function will call directly here. So this is called direct recursion. And indirect recursion, if you are considering in the sense, here it will contain a call to another function. It will not call the same user-defined function. It will contain a call to another user-defined function that itself call the first function. That is the meaning. Okay, for example, here if you are considering in the sense, this is function 1 and this is function 2. And here in function 1, you are passing n as the input value. If n value is 0, it will return n as the result. Else, it will return function 2. That is a call to function 2. So here a function will be called. Okay. And then this function in turn, it will call the first function. So here a function calls by itself only, but through another function, not directly. So indirectly a function calls by itself. In this function, here it calls another function, and in this another function, it calls by itself. Through this another second function, it calls by itself. This is called indirect recursion. Can you able to understand the difference between what is direct and indirect recursion? Direct recursion in the sense, same recursive function calls by itself. Indirect recursion in the sense, two functions will be there. First function will call the second function, and the second function in turn will call the first function. That is the difference. Indirectly, this first function calls by itself through the second function. That is the meaning. Okay. So here there are two functions that are indirectly recursive, both call each other. This is indirect recursion. And next is tailed recursion. A recursive function is said to be tailed recursive if there is no pending operation need to be performed. For example, if a function is called, in the sense the function called will be in main function, and once the function is called, the control will be transferred to the user-defined function, and the user-defined function completely it will be executed. At the end of the user-defined function, what is the result of that user-defined function? That result or value will be returned back to the calling function. This is the normal procedure of user-defined function, how it will execute. Okay. Whenever the user-defined function is returning a call to the function call, that time, if there is any pending operation in the sense, that is called tailed recursion. When the recursive function returns to the caller, if there is a pending operation in the sense, that is called tailed recursion. So here, if you are considering the example, this is the function factorial function with n value, and here it will return, this function will call this another function fact of 1, fact of n comma 1. Okay. So here this second function with n value and result. N value, what is the value you have given, that it will take it. Result will be considered as 1 here. If n value is 1 in the sense, it will return 1 as the result. Else what it will do, fact of n minus 1 comma n into result it has to perform. So here this is fact of 1. So fact of 1 in the sense, this function calls by itself. The factorial function 1 will call by itself. So continuously it will execute. Finally, when it will be matched with the base case, it will return result. Okay. This result will be returned to the calling function. This is the calling function and this is the called function. Okay. Only result it will return. So here there is no pending operation. When this function returns the result to the called function, there is no pending operation here. This is nothing but tailed recursion. For example, here I will consider fact of n. N value is 3. Fact of 3 we will consider. Okay. So this is the calling function. So here it has to return fact of 1 with the n value 3 comma 1. Actually, recursive call will present in this function only. Okay. So here this is fact of 1 with the n value, directly I will take value 3 and result will be 1. So if n value is 1, check whether n value is 1, no, n value is 3. So it has to go to this else part and it will return. So first recursive call, it will return, what it will return? Fact 1 of n minus 1 is 3 minus 1 is 2, comma n into result. N value is 3, result is 1. So 3 into 1, 3 you will get it. Okay. So with this, again the function is called. So with the second recursive call, fact 1 of value is 2 comma 3 it will take it. 2 comma 3 it will take it. Then here it will return fact 1 of n minus 1. 2 minus 1 is 1 and here n into result. N is 2. 2 into result is 3. N value is 2 and result value is 3. So here it will take 6. With this value, again this function is called. This is recursive call. And third recursive call, what it will happen? Fact of 1 comma 6 it will take it. And now it will check it whether n value equal to 1, condition is true, it will return result. What is the result it will return? It will return 6 as the result. Okay, and this 6 only, it will be returned to the called function. Here this is a function call, and what is the result of this function call? In the sense, the result is 6. So when it is returning the call to the calling function, okay, here there is no pending operation, only result it will return. There is no pending operation, directly the value was returned. So this is called tail recursion. When called function returns, in the sense, value should be immediately returned to the calling function. Here fact 1 is the called function, and here this fact is the calling function. Within this function only the fact 1 is called. Okay, and here the fact 1 finally what it will carry, in the sense, the return result is 6 it will carry. Value should be immediately returned. There is no pending operation. Direct value is returned to the calling function. So tailed recursive functions are highly desirable because they are much more efficient to use. Here the amount of information need to be stored with the system stack, that is independent of the number of recursive calls. Okay, so tailed recursive function is highly desirable because there is no pending operation. So system stack does not require to maintain here. It is independent. System stack is independent of the number of recursive calls. Overhead is reduced. Overhead for system stack is reduced here in tail recursion. And in non-tail recursion, if you are considering, if there is a pending operation needs to be performed in every recursive call, that is called non-tail recursion. For example, consider this factorial function. Here, for example, n, I will take it as 3. Okay, so here it will check whether n value is 1. Condition fails, and it will go to else part, and here first recursive call it will return n into fact of n minus 1. N is 3. So n is 3 here. 3 into fact of 3 minus 1 is 2. So here the first recursive call, when it will return here, okay, pending operation multiplication need to be performed. Multiplication is not completed. If you got the result for this fact of 2, then only you can able to implement this multiplication. So second recursive call also, 3 into fact of 2. It will check it whether n value is 1. No, condition fails. It will come to else part and it will implement this return statement. So here n into, n value is 2. 2 into fact of 2 minus 1 is 1. Now this is a recursive call with n value 1. So when this recursive call is made, here pending multiplication operation is there. Multiplication is not completed when the recursive call returns to the called function. Okay, here called function is the same function. Calling function, called function, both the same function. But when it is returning, there is a pending operation. Needs to be performed. Then third recursive call, 3 into 2 into fact of 1. N value is 1, in the sense here this condition is true. It will return 1 as the result. Now it will return 1 as the result. See here in this 2 recursive call, when it returns to the called function, pending operation is there here. Pending operation needs to be completed. Here multiplication is the pending operation. But third recursive call, what will happen? It will return 6 as the result. Here there is no pending operation. So in every recursive call, if there is a pending operation needs to be performed, in the sense, that is called non-tail recursion. So here pending operation multiplication needs to be performed. In this case of non-tail recursion, information about each pending operation must be stored. You need to store it. 3 you have to multiply with this result, that you need to store it. Here 3 into 2 into with the fact of 1. What is the result you will get for fact of 1? You need to multiply with 3 and 2. That is the pending operation here. So these information you need to store it. Here system stack is required to store these pending information. So here each pending operation must be stored so that the amount of information directly depends on the number of calls. This is a non-tail recursion. So the simple difference between tail recursion and non-tail recursion, in the sense, tail recursion, when there is no pending operation, whenever a function call is returned, that is tail recursion. Non-tail recursion, when there is a pending operation, when the function call is returned in every recursive call. During any recursive call, if there is no pending operation, that is called tail recursion. If there is a pending operation, that is called non-tail recursion. That is a simple difference. Okay, this is the example. Next is linear recursion. A recursion is said to be a linear recursion if the function calls by itself only once in every recursive call. Whenever you are executing, every step one recursive call will be there. That is nothing but recursion. Okay, that is the case of recursion. So in every recursive call, only one time the function should call. That is called linear recursion. For example, here if you are considering in the sense, n value is 3 if you are giving, n is equal to 3, it will check it n is equal to 1, condition fails, it will go to else part, and in first recursive call, it will return n into, that is 3 into fact of 3 minus 1, 3 minus 1 in the sense 2. So in this first recursive call, only one time the recursive call is made here. Second time also 3 into with the fact of 2 in the sense 2 into fact of n minus 1, fact of 1 it will make it. Here also only one time the recursive call is made. So here you have to implement like this. So for this fact of 2, this is 2 into fact of 1. And third recursive call if you are considering 3 into 2 into, for this fact of 1, 1 into, for this fact of 1, it will return 1 as the result. Okay. So here. So every recursive call, the function calls by itself only once. It creates a linear chain-like fashion of recursive call. That is called linear recursion. So here each function call leads to one more function call to the same function itself. That is simply in every recursive step, a function calls by itself only once. That is linear recursion. And non-linear recursion, or otherwise called tree recursion if you are considering in the sense, more than once a recursive call is made in each step of recursion. Every recursive step, if the function calls by itself more than once, in that case that is called a tree recursion. Best example is Fibonacci series. That is, we need to find the Fibonacci series for the fourth number. So here n value is 0, it will consider. Here it will check it whether n value is 0, condition fails. Go to else if part, and here it will check it whether n value is 1, here also condition fails. It will go to else part, and here this statement will be implemented. So in first recursive call, what will happen? It will return Fibonacci of n minus 1. N value is 4. 4 minus 1 in the sense 3 plus Fibonacci of n minus 2. 4 minus 2 in the sense 2 you will get it. So in this first recursive call, the function calls by itself 2 times with the n value 3 and with the n value 2. And in second recursive call, if you are considering here in the sense, for this recursion if you are implementing, it will check it n value is 3, this condition fails, this condition fails, it will be implemented like this. So here 3 it will make it. Fib of n minus 1, 3 minus 1 is 2 plus fib of n minus 2, 3 minus 2 is 1 it will make it. So similarly here also it will make 2 times. Fib of n minus 1, 2 minus 1 is 1 plus fib of 2 minus 2 is 0 it will make it. This is second recursive call. See here, in every step of recursive call, function calls by itself more than once. Here in this step it has to call 4 times with n value 2, 1, 1, 0. It has to call. Okay, then only you will get the solution for these sub-problems. Okay, next recursive call also if you are considering, third recursive call if you are considering in the sense, here it will make it. This is the third recursive call. Here fib of 2 in the sense n value is 2, here it will make it fib of 1 and fib of 0. And here it will make it fib of 1 in the sense directly it will return the value 1 it will return. Okay, and here fib of 1 in the sense it will return 1, fib of 0 in the sense it will return 0. And here fib of 1, 1 it will return, fib of 0 it will return 0. All you have to add it. So if you are adding in the sense what you will get? This is 1 plus 0 plus 1 plus 1. So you will get it as 3 you will get it. What is the fourth Fibonacci number? It is 0, 1. Default value, the base case value is 0 and 1. 0th position value is 0, first position value is 1. Okay. Second position value is 0 plus 1, you will get it as 1. And third position value is 1 plus 1, you will get it as 2. And fourth position value is 1 plus 2, you will get it as 3. So the result, you will get it as 3, you will get it. So here, it will make a tree of recursive call. And here, the recursive function, in every step of recursive call, it has called more than once. In the first recursive call, 2 times. Second recursive call, 4 times. Third recursive call, 2 times. So if the function calls by itself in every recursive call more than once in the sense, that is called tree recursion. If it makes only one call in every step of recursive call in the sense, that is called linear recursion. So this is linear and non-linear recursion. So now can you able to understand the difference between all recursions? If it is a direct recursion, function calls directly by itself. Indirect recursion, through another function, the function will make a recursive call. That is indirect recursion. Tailed recursion in the sense, if there is no pending operation when the recursive call is returned. If there is a pending operation when the recursive call is returned in the sense, that is called non-tailed recursion. Linear recursion in the sense, in every recursive call, function calls by itself only once. That is linear recursion. Non-linear recursion or tree recursion in the sense, in every recursive call, function calls by itself more than once. That is called tree recursion or non-linear recursion. So these are all the different types of recursion we will use in C program. Thank you for watching this video.